Hello everyone. Soon we'll start within a few minutes. We are still waiting for Mr. Rob Seville. Hopefully he is able to appear. He has some urgencies, but definitely we are going to start soon within a few minutes, and that wouldn't hurt the agenda anyway. So you just have to wait for about 3 minutes and listen our funny jokes here that we are going to tell. So
I wasn't told that I had to bring jokes.
That's a good
it
one.
wouldn't have made the difference in my case.
Yeah, exactly. Yeah. All right. It's very nice weather here in Finland. It's actually they have promised 2 weeks of +10 to +15 around there in the southern parts of Finland, and sun is shining next 2 weeks at least.
That's not bad. It's sunny here, but for this time of year, for us, cold. I think it was about 40 Fahrenheit. So that's a little chilly for us, but it's nice. And bright sun helps a lot.
Yeah, exactly. Yeah, it really changes the scene, as they say.
Yes, it does.
How about in Italy, Gianluca? Is it like 30 Celsius and so forth?
I wish. So yesterday we had 13 degrees Celsius as the maximum temperature. I don't know what that is in Fahrenheit, but it's a bit chilly for the time of the year. We also had snow a couple of days ago on the mountains just above where I live. So it's unusual to see the snow on the mountains at this time of the year.
Okay, yeah. So spring is coming slowly. All right, I think we are good to start now. So as I said, hopefully also Rob will appear soon if possible. So today we are talking about capacity planning and licensing review in this series of webinars around topic of mastering SQL Server migrations. And there is lots of things that I think that we think that is very valid for the capacity planning purposes. So I hope that you get lots of good ideas in this webinar. First of all, I mess with these PowerPoints always. Okay, so here the agenda is first a brief introduction, then about 40 minutes of panel discussion, and we leave about 10 to 15 minutes to Q&A in the end of the webinar. So because we start 5 minutes late, so it's basically about 10 minutes for the Q&A and summary. And first of all, the first panelist, Matt. Hello. And yeah, so as you can see, Matt is a Microsoft Data Platform MVP and the developer / DBA and director of database management at Rev.io in Kentucky, USA. So and Matt has worked with SQL Server since 2000, so over 20 years. And also Matt is a leader in the Lexington KY Data Technology Group and frequent domestic and international community speaker, IDERA ACE alumnus, and also 2021 friend of Redgate. Then Rob, who is hopefully attending soon. So he's Microsoft Cloud and Data Center MVP and Data Platform MVP, founder and developer and DBA in Savolainen Consulting in United Kingdom, and Data Saturdays encourager and frequent domestic and international community speaker. Gianluca, hello. So Gianluca is also SQL Server MVP and founder / developer / DBA as well, and located in Italy, sunny Italy. And he has a company called SQL Consulting.it and worked since SQL Server version 7, and also frequent domestic and international community speaker. And my name is Jani Savolainen, and I'm founder and CDO of SQL Governor and also founder of DB Pro Services. I'm a developer / data scientist, jack of all trades, king of none, located here in Helsinki, Finland, and 21 years experience with SQL Server. First version I've touched was 6.5. Those were the days. And also former chairman of the PAS Finland chapter. Alrighty, so first of all, this picture with one with which always we start with. So here you can see all the kind of typical phases of the migration process. And today we get into a capacity planning and licensing review, which is here. You can see here. And last time we discussed just a bit about the technical planning meetings, so we are not going to focus in that area. But typically when doing the capacity planning, those meetings should be done. At least they should be finalized during the period of capacity planning, because it really affects you have to know the architecture, you have to know the external dependencies, you have to know all the kind of business impact stuff and all that stuff there before doing the actual capacity planning. So first of all, we are going to talk about philosophy in capacity planning, because there is kind of like everybody knows, for example, like a data warehousing, there is different schools. There is a Imnon school, and then there is a Kimball school. So wherein the Bill Imnon says that, okay, data warehouse should be like this, then Kimball says, I think he's Ralph Kimball, if I remember correctly, he says that it should be like this. So there are two different philosophies that fit in certain use cases just perfectly. And today we are also going to discuss when the replay-driven capacity planning is perfect match, and when the statistics-driven capacity planning is a perfect match for your capacity planning needs. There are two different philosophies. But first of all, we want to ask Matt, how is world in licensing side?
Complicated. So this, I'm not going to deep dive into the nuances of licensing and all the different programs and all that, because they changed quite a bit. What I will say is, as you engage in a project like this, it is important to engage with whatever representative you have access to, and that's going to depend on the size of your shop and all that. It might be Microsoft, it might be a reseller, but definitely reach out to them and understand, get an initial quote, obviously, but ask about what other programs you may be able to be involved in. Depending on how your stuff is licensed on-prem, there are options like the Azure hybrid benefit that's offered through Microsoft only, but there's programs like that. Depending on the size, there are volume licensing, whatever that's called now, and all those sorts of things. So definitely not here to explain how all of it works, because it's very fluid. But please engage with a rep. I would say early on. because you need to understand, like I can think of projects that I've been involved with where we were given a bit of misinformation on how the things were licensed in a current data center. And when we got the correct information, Azure Hybrid was actually an option for them, and it cut their licensing cost almost in half. So it's really important to have a good understanding of your whole license picture now, what you can do to make that look bigger, especially if you're a company that's grown by buying other firms and things like that. It can be useful to consolidate all those under one umbrella before engaging in a project like this, because you're going to find advantages from that.
Yeah, exactly. And one thing I want to kind of also point out is that when companies grow bigger and the SQL assets grow bigger, it's quite typical that there is even person dedicated to just to manage the licensing, because it's so its own world. And also, what comes to software assets, it would be a good idea to have, for example, like external software asset management company to help from the licensing perspective to optimize that setup. And actually, capacity planning is a combination of doing the kind of in migration process. It's combination of doing that technical part and then negotiating with the licensing party. And in that way, you can get the optimal results there.
Yeah, I would say one of the lessons I've learned, and obviously this is going to depend on the size, where I work now, we'll be engaging in this later this year. But for me, it's pretty straightforward. I know all the servers we have, and I know the resources they need and all of that. But larger projects, it's not quite that simple. So it can be a good role for like a project manager or something like that to do what you said. Either use the tools we've talked about in earlier sessions to get an idea of every server you have, and maybe different business units own different ones or whatever, but you can still get that kind of volume discount, for lack of a better phrase. But have somebody in the project putting together what you'll be migrating. It sounds simple. It sounds like an obvious thing, but in large projects, I've seen that get done too late so many times that I wanted to kind of mention it here, because I can think of a handful of times where it's like, oh, we discovered these other 80 servers that this business unit owns, but it actually counts for this. And A, we have to move them, which is not great news as the project goes on, but B, it gave us substantial discounts, which is good news. So it's important to consider this, even though licensing, it's complicated and it's not fun to talk about because you're talking about money and all those sorts of things, but it really is a critical foundational piece.
Exactly. Yeah. So I think that it would be a good idea now to go into the core of the topic, so the capacity planning itself. And let's kick this off by Gianluca's brief presentation of what is a replay-driven capacity planning. What is the philosophy of that?
Good. So how you said, we have basically two ways of addressing a migration process. And one is by using a replay-driven strategy or a statistics-driven strategy. What's the difference? Basically, with replay-driven strategy, what you try to do is take your whole workload, try to record it in production, and then you try to replay it on the target environment that you chose for your migration. And as you can imagine, this is not an easy task. This is not something that you can easily do, but it's not impossible. All you have to do is plan correctly and use the correct tools for that. The main idea behind this is that you rely on tools that will try to mimic your production workload in your target environment. And obviously, this cannot be done 100% correctly or exactly. There will have to be some degree of approximation in this process, but what you end up with is a simulation of what your workload would look like in the target environment. This means that if you are moving from a newer version of SQL Server, you're also going to test how that performs, which is a bit different from what you get with a statistics-driven capacity planning strategy. In that case, you are relying on numbers, but you're going to tell us about this shortly, Jani. But in that case, you are not comparing the actual behavior of the application, but you're just comparing numbers. With a replay-driven strategy, you're actually running the application, or, well, a mock-up of the application that tries to put the same load on the target environment. And that also allows you to see how that workload is running on the target environment if it is different from what you get in the source environment. So this covers version upgrades or migrations to the cloud from on-prem to SaaS or IaaS solutions. And that also helps you evaluate how the storage or other components in the stack are affected by the application.
Yeah, exactly. So then about the statistics-driven capacity planning. Philosophy in statistics-driven capacity planning is that when you have a lot of servers, instances, databases, it's a very good idea to track and monitor those changes in the workloads in the long term. So for example, you take at least 2-3 consecutive months, and even sometimes if you have like a continuous monitoring software in use, you're able to take even years of that data. And all of a sudden, when you have years of that workload data, you're able to not only understand the trends for average CPU component, the peaking CPU component, the RAM component, and all the storage latencies, IOPS, throughput, so forth, and how the storage capacity is going to increase. You also understand how the service breaks and service time, out of service time, affects your environment, and this is kind of like benefits from the statistics-driven capacity planning. It's also more scalable because you can just monitor all that infrastructure, servers, instances, databases, and even data files, and then you're able to identify those workloads and make planning based on that information. So kind of in a nutshell, there are places wherein I would definitely use replay-driven capacity planning, and then cases where I would use statistics-driven capacity planning. And both are good, but in some scenarios, there is benefits to use one from another. Matt, do you want to say something about this?
Everything both of you just said is right.
All right.
Yep. Yeah, I mean, there are times because, you know, you'll see people argue one versus the other. Well, one is obviously the best because you're testing real stuff. But one is obviously the best because you have real numbers from things that happen. There's a time and a place for both, and there are good tools for both.
Yeah, exactly. Yeah. One thing maybe to mention also that, for example, if you take the statistics-driven capacity planning, all of a sudden you understand also the service levels of your performance counters. For example, if you make contention analysis, if you get just a peak point few days or 1 week, you may not get the SLA understanding from the CPU contention, for example. So this is one thing also to mention. Okay, then the scenarios. What are the capacity planning scenarios? And first is scenario that we are going to cover here is on-premises to on-premises. And I can start with that. So on-premises to on-premises, for example, if you have a physical hosted environment, or you have virtualized environment and you want to move from physical to a virtualized, or from virtualized to physical, or a mixture of them, or anything in between. So this is the on-premises world. And actually, it's not uncommon to have about 40% savings in licensing costs, and also big amount in hardware and virtualization environment costs when you are doing the capacity planning and right sizing and consolidation in such environment. And when it comes to on-premises, maybe the scenarios are the most simplest and most optimal for capacity planning, because pretty much you're just playing with the things like benchmarks of servers, and you can divide those benchmarks, split them into VMs, you can split them into a socket level, you can use them even like CPU core level, you can control the nuances of what is the single core performance versus the whole processor performance, so forth. And all of a sudden, when you have these elements in the scenario, if you're using statistics-based capacity planning, you're able to take and track the time series of your data, which is good to have at least 1 hour granularity aggregations on performance, and the interval to take these samples would be like 1 to 2 minute interval, and then to aggregate those things. So to get the contents and analysis of CPU also involved. And then you would need to have, like I said earlier, service breaks, service times, because for example, if you have patching, typically the server takes all the capacity there. So if you are going to trying to right size your environment based on the highest peaks on average and peaking CPU, you're never going to optimize anything, because maybe some out of service time batch that has many hours of time to process, it does it like in 30 minutes or so, and it's CPU intensive and it takes all the CPU. So you don't want to right size your environment based on that information that, okay, CPU takes 100%, because it's irrelevant if your daily workloads are, for example, 10% level or 5% level on peaking CPU. I have seen such scenarios. So that's why it's important to have the time series, being able to exclude service breaks, service time, the limit to service times, and also to have the trends of the components and things like that. I'm not talking now about replay-driven workloads, because I know Gianluca has better knowledge on that, and maybe this statistics base is more my comfort zone, definitely. So that's in on-premises. What's also should be taken in account in on-premises, if you're moving, for example, to a dedicated storage to SAN environments, and you change the storage there. So all the things considering the latencies and the importance of understanding the growth of your throughput and things like that, they become very important, because the data workloads grow so much over the years. So you benefit definitely from having this kind of statistics-driven model if you have many years of data already that you would benefit from, or at least like 2-3 consecutive months of monitoring data to be able to use there. So I would say that on-premises to on-premises is pretty straightforward, but you need a certain amount of math there, and there is software around to do that. For example, like SQL Governor software that is able to do that kind of heavy lifting and automate, for example, the consolidation of servers, instances, databases, and harmonize the workloads. That is very important in capacity planning. For example, if there is 2 instances and one is active on 2 p.m. always, and another is never active on 2 p.m., it may be a good idea to put them together when looking at the different components of the performance counter workloads, because you can see that instead of like this, they go like this. So then you don't need that much of capacity. That's something I would like to maybe point out here. And then another scenario on-premises to cloud, what are the differences in scenario of on-premise to cloud migration in terms of capacity planning, Matt?
Well, for me, kind of the first thing that comes to mind is you're trying to, you're not consolidating servers and, like you said, kind of comparing times of workloads and seeing how much you can put on one box. When you're going to the cloud, whatever cloud it is, you're trying to fit your workload. You're either consolidating it onto a VM, but more likely, because I think you realize more savings when you do this, if you're looking at a platform as a service offering, you're trying to figure out where your workload fits in those tiers.
Yes.
Because it's not like you can say, well, I want 4 gigabytes more RAM here, because that'll be, you don't get that choice. You get at that tier, you get what you get. And so that, I think, that's the main difference for me. And obviously, going to a VM in the cloud somewhere, everything you just said there pretty much holds true. You're still dealing with tiers in cloud-based VMs, but I would argue they're more flexible than the platform as a service offerings, but they're also, I think, not as cost effective generally. So yeah, I mean, I know, just kind of speaking for our own project later in the year, platform as a service is where we'll head. And I know I encouraged a lot of my customers over the years to do the same. And I know we talked about it in earlier sessions, but what's important to consider here and why this type of planning is important is it is, I will say, nearly impossible to save money in the cloud taking your footprint as it stands on-prem and putting it up there.
Yeah,
it's doable, but it's generally more expensive.
Yeah.
Yeah, I mean, if you're just trying to tick a box and say we've migrated to the cloud and you're uncomfortable with any change other than that, then you've ticked that box. But in terms of saving money and getting the real value out of the cool stuff that cloud-based databases can do, you really need to rethink your positioning of all those assets, because you need to go to the cloud in a smaller footprint to save money, and then you can take advantage of all that. Yeah.
Yeah, and one thing also, for example, like if you're you don't have to kind of decide that, okay, whether I'm going to IaaS or PaaS, or even like okay, Gianluca maybe tells something about the comparing the clouds and so forth. But for example, many cases when you have a lot of servers, instances, databases, they have their own history. So there has been application or two, or quite a swarm of the applications and software on top of them. So when you are proceeding the analysis, preliminary analysis of the each application and software and server instance, so forth, maybe even a database if there is not that many databases, but I've seen environments of like 50,000 databases, so you don't want to analyze each database, what is purpose of this database, you just cannot do that. So what I mean is that you kind of get the understanding that, okay, these are the servers that are good candidates, maybe we just keep them on-prem, maybe we virtualize them. It's not possible, for example, to put some legacy software and refactor them in the cloud. So also it may be that some of the servers are using reporting services or analysis services, integration services, so they are perfect candidates for IaaS then, if there is lots of code on top of that area. And then platform as a service, I agree that there is possibilities to optimize, because you are actually having so much automation on PaaS layer. So on that tier, you get so much things like, for example, always on, if we talk about Azure. So that's wonderful built-in functionality there. And also, if you have, for example, managed instances, you're able to take the long-tailed smaller instances and make the consolidation of those instances and databases into managed instances. So when you optimize those workloads, you end up getting savings there.
Yeah, well, and those are great points, and really it's likely to be a blend. You know, you probably can put your servers and your customers that are on those or whatever into certain t-shirt sizes, right? Small, medium, large, extra large. And maybe all the small, medium, and large end up on some flavor of Azure SQL, managed instance, whatever. And the extra largest maybe need a VM because they have particular performance needs that maybe a PaaS offering wouldn't really suit. So yeah, the main thing with all this, there's no one size fits all answer. And that's why the planning tools help, because you can categorize those. You know, you may have one server and you've got a customer that's 5 times larger than any of your other ones, and they have special needs there that nobody else does. So you're going to do the planning one way for everybody else and do really kind of a different study for them to make sure they land in the right cloud spot.
Exactly. So then cloud to cloud scenario. Gianluca, would you tell about that?
Well, this is something that I have seen very rarely, and it doesn't happen very often. What I can say is that when it happens, it's because there's some cost saving. So maybe the target cloud offering that you chose to migrate to has a model that better suits your workload, so it lets you save some money. It has the perfect t-shirt size, to use Matt's analogy, for your workload. Or maybe it has that killer feature that you can find in that particular cloud environment. This probably applies more to platform as a service scenarios. The differentiation on features. Maybe infrastructure as a service, there are different factors there at play. Among the different sizes of t-shirts, there are things that are more important for your workload. So maybe your workload is more IO intensive, so there's a better VM size or a platform as a service tier that has a correct IO size for your workload, and maybe the source cloud environment doesn't have exactly that. Or maybe in order to have that IO size, you need to also buy a lot of CPU that you wouldn't use. So this is a kind of cases that I've seen for cloud to cloud scenarios. Obviously here, the tricky part is getting the different restrictions in different cloud environments to work with your application. And this is why you want to capture those restrictions before you hit production, obviously. So it's not strictly things in the workload itself. It might also be in tools that are around your application that maybe monitor how your application works, or even tools for the migration itself that stop working because in that particular cloud environment you don't have the feature that is used by the tool itself. So it's one of the trickiest possible scenarios, and actually I haven't seen it very often.
And acquisitions happen. So in those cases, that is a scenario also, and that can cost a lot. Even though the target platform would be cheaper, it can cost a lot. So yeah, exactly. That's a kind of maybe one of the most challenging scenarios. Then these sub scenarios, as we put here, so there are different scenarios, and because now Rob is not here, he would have been a perfect candidate to tell us about the virtualization. So a couple of words from virtualization. So first of all, when you are planning against virtualized platform capacity, so you have to know, you have to take the snapshots of the hosts on existing VMs if you are going to change the VM sizes, for example. So you understand that this VM has, for example, 4 virtual cores, they are hyper-threaded, and then the host has 18 cores of this and this CPU, at that point of time, given point of time, the capacity all the time when it's residing on that host is this and this much. All of a sudden, you're able to then calculate, extrapolate the difference in between the existing CPU against, for example, the target server, if you resize the VM on a certain level, for example, in case of consolidation. And actually, when talking about sub-scenario of consolidation, you can do the consolidation on database level, instance level, and the server level. So basically, if you're doing the server level consolidation, it pretty much means that, for example, if you're on-prem, you have a certain physical host, and then you derive these source servers into this physical host pool, for example, like 4 machine workloads independent of if they are physical or virtual. You can pinpoint to a certain sites of the virtual machines under the host, and the capacity planning software is able to calculate you to optimal VM sites based on storage, the RAM, the CPU, and also taking a contention analysis, which basically means, I've talked a lot about contention. It's important, especially when you consolidate, because that tells the risk level of system slowing down. And contention happens when, for example, the CPU, peaking CPU workload exceeds 80% limit. And at the same time, there is at least 2 times or more logical core numbers length of processor queue. So basically like 3 times, 4 times, so forth, especially in such cases. I have seen numbers like a decade, 1/10, actually 10 times higher. So, but anyways, in that case, if that continues 5 minutes or more continuously, it starts to create slowness in processing, and this endangers the whole production basically. So everything starts to slow down, and then everybody knows what happens in the end if this lasts for a very long time. So contention analysis is super important, and also the failover analysis. If you have a clustered environment and you are consolidating that, for example, like you have a 2-node active setup, and you have, for example, 4 instances here and 4 instances there, and if you have, for example, like 4 nodes, and you just think about ping pong around there, and if failover occurs there, so in such scenario you have to calculate your SLAs based on the failovers and also based on the contention probability, how they will collide, those contention areas in the history predicted to the future. So that's super important in consolidation. And then when you're doing the instance level consolidation, it's more like you just take the instance workload, and then you can put it, for example, IaaS, VM, or target can be a virtual machine on premises, or it can be even like a managed instance if you stack them into a managed instance, which is pretty cool way to do. So this is kind of the same philosophy is working there. You just take a proportion of the VM or physical host workload, and you can even automate that. For example, like with SQL Governor, you can automate the whole process with machine learning. And also the database level consolidation is super nice way when you don't have maybe that many servers, but you have lots of databases and lots of instances. So instead of having databases that are having at the same time like volatility, and then they are having the kind of the heavy hitters that are hitting the ceiling every now and then there is this kind of stable normal, let's say normal and decent workloads. So you may want to categorize these into different categories, and based on those categorizing characteristics, you're able to isolate certain kind of databases into these different kinds of instances and harmonize them over the target servers. So all of a sudden, your throughput is much bigger in terms of CPU, RAM, the storage, and so forth. So that I would like to say about consolidation. Then there is physicalization. Would you like to say something about this, Gianluca or Matt? This was Rob's topic also, but now he's not here, so we can cover him.
Yeah, I mean, I think what we were going to talk about here, and I know we've got other stuff to get to, so I'll try to keep this brief. I
Okay,
think what
yeah,
we were talking about here was particularly, you get those servers and those databases that have performance profiles that are very intense, that
yes,
maybe you've decided virtualization is not a good option for them because they need that last little bit of speed that they just can't get any other way but like a bare metal server. So, you might be migrating from a virtualized host to that. Um, that is my recollection of our chat about this. So hopefully that's right.
yeah, exactly. And when the other workloads are very volatile, that's also the thing
Right.
you want to isolate, that more stable and more critical production workload. That would be another scenario, and there are different scenarios for this. Okay, then upgrades, and Gianluca, I think you have something to tell about that.
Well, upgrades are one of the main scenarios for this kind of work. And one of the critical things to do here is making sure that everything works in the new environment as it was working in the previous one. So things that you want to catch here is both features that went away because they were deprecated, and there are ways to do this. You can capture this by analyzing your workload before you start the migration. And the other scenario you want to take care of is making sure that performance looks the same in the target environment. And this is particularly tricky when you want to change the compatibility level of the database, maybe to take advantage of one of the new features enabled by raising the compatibility level. This also changes the way that database behaves. So you may get some regressions on some queries, and it's particularly important to catch those regressions before you hit production. As we mentioned in other webinars in this series, Microsoft guarantees that if you keep the compatibility level of your database stable, you won't get any of those regressions. Well, actually, the experience suggests that it's 99% like this, and you really want to catch that 1% before hitting live.
Yeah, very good point. I think you're referring, for example, to cardinality estimator changes,
Yeah,
for example,
absolutely.
in the SQL Server.
That's a big change that was introduced in 2014.
Yes.
But there are some other small changes in the way the database and the optimizer works. And other than big change, you also want to catch those up front.
Yeah, very well. Then one of the sub scenarios is cloudification. Matt.
I think that was Rob's phrase. But yeah, I think that was just kind of a catch-all, and it kind of goes back to what we talked about earlier, I think, where understanding the capabilities of what the cloud can do, whoever's cloud it might be, and molding your current setup to that. Realizing that, like we've talked about, there are opportunities to consolidate at the different layers for different reasons. And so I guess I would argue it's more cloudifying your thinking and allowing that to cloudify your data setup.
All right. We have lots of things still to discuss and not that much time, so let's go forward. So then, Gianluca, please tell us a bit about more practical, in a more practical way, that what are the kind of basics of replay-driven planning, like in a nutshell?
Okay, so very quickly, as we mentioned, the idea behind this is that you capture your workload in production and you try to replay that workload against the target environment that you chose for the migration. Obviously, there are some limitations to this approach, and there are some benefits over the statistics-driven method. The main difference is that in this case, you try to rerun the same workload, and it won't be possible in those cases where the workload is too big to be captured or the target database is too big to transfer to the target environment. So in those cases, you probably want to use a statistics driven comparison method. So the phases that you will have to go through is a first phase where you capture the workload. So here, what you want to do is observe and capture your workload for a meaningful amount of time. That has to cover the complete business cycle. So if you have things that happen only once a week, you probably want to capture a complete week of work. If you have things that happen once a month, you probably want to capture a whole month of activity in order to make sure that everything that's in the workload gets taken into account in the comparison. And then you probably want to do a replay to compare how the workload behaves in the target environment. So if the capture is aimed at a short amount of time, you may want to run the replay after the capture. There are some cases where the window that you are capturing is too big to be replayed afterwards because it would create a huge capture file, or it would be too big to process. So in those cases, what I suggest is to run real-time capture and replay. So all the queries that hit the production environment also hit the target environment that you want to use for the migration. And there's one feature in workload tools that allows you to do exactly that. And after you have your capture and replay set up, what you want to do is compare the performance numbers that you get from both environments and see where are the criticalities. So if you see that you are using more CPU, you probably want to dig deeper and find out what is the cause of that difference. If the response time is not good enough, you probably want to go and see whether it's caused by the IO configuration or what else is involved in the process. Regarding tools for doing this, well, it depends. If you are on-prem, you have tools for this that come from a very long time ago. You have things like the RML utilities that can help you do that. It's a set of tools that's been around for, I wouldn't say, I don't want to say too much, but I think at least 15 years. And those are based around the trace feature in SQL Server. So what you do is you capture a trace, and after that you replay it and you compare the two after processing the two traces of the two environments. Other tools for this, you have one tool from Microsoft which is called the DEA, the Database Experimentation Assistant. This is relatively new, so there are still some tough spots, but you definitely want to check that out. And also there is Workload Tools, which is an open source tool that I created. You can find it on GitHub. And what it does, it's based on extended events and for older versions also on SQL Trace. And you can capture and replay and compare your workloads using directly the features included in the tool set. And it's pretty straightforward to use, and it has a couple of features that allow you to use it in cloud scenarios, which is something that is particularly difficult to do with traditional on-prem tools like RML utilities. It also has the ability to do this real-time replays, which is a unique feature which is not found in any other A/B testing tool.
Alrighty. Then just a few words about statistics-driven planning, and then we go to real-life scenarios, the cases what we have done in capacity planning, and tell about their characteristics. So I would just say that the statistics-driven capacity planning is kind of the benefits over statistics-driven method I pretty much told already, so I'm not going to go there. But the idea is to first monitor the workloads, capture those workloads, all that data, the more the better. And then after the monitoring part, you're actually adding up certain things there, like you're spicing the data to get it more, how would I say, versatile. So you add there like the service times, the service breaks, continuous ones, the one-time service breaks, for example, things like that. And then you add in certain metadata there, you understand what is development, test production, all that stuff, what kind of templates you want for your production, for example, based on SQL Server version, or if they are going to be in a cloud, for example, in AWS or Azure or so forth. And then do the capacity planning that is pretty much automated in software like SQL Governor, which is SQL Governor software, software from SQL Governor. So and also the reviewing of capacity is possible there, so you're able to see how the plans actually worked out, and comparison of that. There is also a Microsoft tool called Movere, but it's more like a general assessment, discovery, capacity planning software, instead of being particular software in addressing the automated consolidation and right sizing of the SQL servers. So, but that's something you would also check out. Yeah, Matt, please.
Yeah, and that's only available through Microsoft partners at this point. So you're not able to phone somebody up and say, I would like this. Movere you can get, but you have to work with a partner to do it. So if you don't feel like engaging with a partner is right for you, that's not going to be an option for you.
Exactly. Then the last thing before the questions is the real world cases. So one case, for example, is the database consolidation. So I have done a couple of database consolidation cases, and they are very kind of, how would I say, very nice ones. So the idea there in statistics-driven capacity planning, and you take the proportion of the Planck as a buffer pool usage of the databases over time, and also the CPU time compared to the instance level CPU usage, and all of a sudden you understand the kind of a proportional usage of the database workloads, and also of course the storage, all the storage constraints there. So performance counters on that area, and then you're able to map them and visualize them into different categories. For example, as I told, like a high volatility and heavy hitters and ordinary workloads and so forth. And then by using machine learning, you can optimize and harmonize those workloads, how they are most balanced over time, because always you want to have a balanced workload, balanced baselines. That's what you want to have. And I have good experiences of doing such things. Database consolidation, I must say honestly, I haven't done so much, but because SQL Governor nowadays supports that already on built-in the monitoring from a whole stack from the database files to the server level, it can do that job. So definitely going to do those cases more in the future. Then there is Rob was one who should have told about would have told the storage upgrade case, and then there is about the version upgrade case that Gianluca has. So before we take this last high volume, high availability environments, what I love, I have one environment I just planned, actually the last iteration I did for that environment during this beginning of this week, it has about 50,000 databases. So that was quite a nice experience. But please, Gianluca, tell us first, before that, a little bit about version upgrade, real world case.
Well, I've had quite a few database upgrade scenarios in the real world. One that was really tricky was a high load environment that was working 24/7 in a SQL Server 2008 R2 SQL Server, and they wanted to upgrade to SQL Server 2017. So what we did in that case, we used workload tools to capture the workload and replay it in real time for a very long time. We, compared to what we could do with RML utilities, we kept that going for 1 week. So we had 1 week of data that covered the whole business cycle. And then we did some comparisons between the source and target environment. We have seen that changing the compatibility level on the database had some effect on the workload. So we went on and we tweaked some knobs on the target environment until we got the performance that we were expecting. And that was a very successful case of migration that took place with a very minimal downtime and predictable performance in the target environment. So everyone was really happy.
All right. So I tell just a couple of words of this environment. So this environment is quite special because it has like about a dozen of servers, and in that environment actually there is like active high availability clustering configuration, and because those servers have only a few instances on each node, so you just imagine that if you divide 50,000 databases on those instances, it's quite critical to understand the level of contention as a function of, for example, of a size of the database, or as a function of a certain workload profile of the database, how all of those databases are aligned, and what is the optimal set of databases for each instance and node. And also, when the system grows, one day there is 100,000 databases, then there is like a 200,000 databases, so forth. So if you want to keep the costs on a relevant level there, it's super important to understand those workloads and to be able to do the workload failover analysis, the contention analysis, and see how I can reach 99.99 something, for example, workload SLAs in this environment without endangering the production, for example. So you can say big buck there in this kind of scenario, and that's something super nice. I like doing small environments and large environments, but this is one of my favorite environments where I have worked with. All right, so then we have like a 2 minutes, not 10, but 2 for questions. And let me see the questions here. Okay, here they are. And questions. Now you can write those questions because I cannot see any question. Does this mean that everybody is satisfied with the content?
Perhaps.
It seems like we don't have any questions. I try to still double check. Okay, questions, so answered questions, non-answered questions.
Well, I think that means we've described everything perfectly.
Yeah, exactly.
Yeah.
That's the case, of course. So thank you so much. And actually, what we are going to discuss next time, it's about the detailed specification. That is once again quite important part of the migration project. If you don't do the detailed specification, you end up having surprises during the journey. So thank you very much, everybody, and follow us in Twitter. Some of us are more active there and some less active. And here you can see SQL at speed, Spaghetti DBA, SQL DBA with the bird, Cyber Sigma. And then it's time to thank you all and see you next time. Bye-bye.
Goodbye.